Hello children, exercise 13.1, question number 21. Evaluate the given limit. Limit x tends to 0, cosecant x minus cot x. At x equal to 0, the value of the given function takes the form cosecant 0 minus cot 0, which is infinity minus infinity. So we are writing this limit as limit x tends to 0 using law of reciprocals, 1 by sin x minus cos x by sin x. So we get limit x tends to 0, 1 minus cos x by sin x. Divide the numerator and denominator by x. Multiply and divide by x so that we can write the result as a form limit x tends to 0, 1 minus cos x by sin x by x, which is equal to limit x tends to 0, 1 minus cos x by limit x tends to 0, sin x by x, which is equal to 1 minus cos x by x is 0 and this is 1. Using the result limit x tends to 0, 1 minus cos x by x equal to 0 and limit x tends to 0, sin x by x equal to 1. So 0 by 1, which is equal to 0. 23rd question. Find limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x equal to 2x plus 3 when x is less than or equal to 0 and 3 into x plus 1 when x is greater than 0. The given function is f of x, which is equal to 2x plus 3, x is less than or equal to 0, 3 into x plus 1 when x is greater than 0. Here at x equal to 0, the function is 2x plus 3. So 2 into 0 plus 3, which is 3. So limit x tends to 0 f of x, which is equal to limit x tends to 0 2x plus 3, which is equal to 0 plus 3, which is 3. Now we have to find left hand limit and right hand limit. If all the three values are same, then we can say that limit x tends to 0 f of x exists. So to the left of 0, we have the function is 2x plus 3. So limit x tends to 0 minus, which is the left hand limit, f of x, which is equal to limit x tends to 0, f of x is 2x plus 3. Put x equal to 0, we get 3. Now we have to find right hand limit. Limit x tends to 0 plus. So right hand limit is denoted by plus f of x, which is equal to limit x tends to 0. F of x is to the right of 0, we have the function is 3 into x plus 1. Put x equal to 0, we get 3. Here we can observe that limit f of x, left hand limit and right hand limit, all the values are 3. So limit exists. Second one, limit x tends to 1 f of x. At x equal to 1 or x is greater than 0, the function f of x is 3 into x plus 1. So limit x tends to 1 f of x, which is equal to limit 3 into x plus 1. Put x equal to 1, we get 6. And left hand limit x tends to 1 minus f of x, which is equal to the same function 3 into x plus 1. So substituting this, we get 6. And right hand limit x tends to 1 plus f of x, which is equal to the same function 3 into x plus 1. Substituting this, we get 6. Therefore, left hand limit equal to right hand limit, which is equal to the function which has same values, 6. 24th question. Find limit x tends to 1 f of x, where f of x equal to x square minus 1 when x is less than or equal to 1 and minus x square minus 1 when x is greater than 1. So at x equal to 1, we have the function x square minus 1. To the left of 1, we have x square minus 1 since x is less than or equal to 1, and x is greater than 1, we have minus x square minus 1. So left hand limit limit x tends to 1 minus f of x, which is equal to limit x square minus 1, which is, put x equal to 1, we get 1 minus 1, which is 0. And right hand limit x tends to 1 plus f of x. To the right of 1, we have the function minus x square minus 1. So put x equal to 1, we get minus 1 and minus 1, which is equal to minus 2. Therefore, limit x tends to 1 minus f of x, which is not equal to limit x tends to 1 plus. That is, left hand limit and right hand limit are not equal. Left hand limit is 0 and right hand limit is minus 2. Since they are not equal, we can say that f of x does not exist. Twenty-fifth question. Evaluate limit x tends to 0, f of x, where f of x equal to modulus of x by x, and x is not equal to 0, and this is equal to 0 and x equal to 0. We will find both left hand limit and right hand limit. If they are equal, then the function exists. If they are not equal, the function does not exist. Left hand limit, limit x tends to 0 minus f of x, which is equal to limit x tends to 0 modulus of x by x. When x is negative, then modulus of x equal to minus x. So we'll write this as limit x tends to 0 minus x by x. So limit of minus 1, which is minus 1. Then right hand limit, limit x tends to 0 plus f of x is modulus x by x. X is positive, so that x equal to x, modulus of x equal to x. So we have limit x tends to 0 plus x by x, which is 1. So limit of x tends to 0, 1 equal to 1. Here we can see that left hand limit, which is not equal to right hand limit. Therefore, limit x tends to 0, f of x does not exist. 27th question. Find limit x tends to 5, f of x, where f of x equal to modulus of x minus 5. Here we have limit x tends to 5, which is x is greater than 0. So modulus of x equal to x. So left hand limit x tends to 5 minus modulus of x minus 5, which is equal to x minus 5. Put x equal to 5, we get 0. And right hand limit x tends to 5 plus x minus 5, since x is greater than 0. So we get 0. So left hand limit, that is x tends to 5 minus f of x, which is equal to limit x tends to 5 plus f of x. Since left hand limit and right hand limit is equal to 0, we can say that limit f of x exists. Therefore, limit x tends to 5 f of x, which is equal to 0. 28 questions. Suppose f of x equal to a plus bx if x is less than 1, f of x equal to 4 if x equal to 1, f of x equal to b minus ax if x is greater than 1. So at x equal to 0, we have the function is 4. To the left of 1, that is when x is less than 1, we have the function a plus bx. To the right of 1, the function is b minus ax. It's given that limit x tends to 1, f of x equal to f of 1. So first we have to find left hand limit and right hand limit. If both are equal, then we can say that f of x exists. It's given that f of x equal to f of 1. We have to find the possible values of a and b. Left hand limit x tends to 1 minus f of x, which is equal to the left of 1 we have a plus bx. Put x equal to 1 so that we can have a plus b. Right hand limit x tends to 1 plus b minus ax, which is equal to, at x equal to 1 we have b minus a. It's given that limit x tends to 1, f of x equal to 4. At x equal to 1 we have the function is 4. It's given that f of x equal to f of 1. F of x is 4. So f of 1 is also 4. Limit x tends to 1 minus f of x, which is equal to limit x tends to 1 plus f of x, which is equal to limit x tends to 1 f of x, which is equal to f of 1. Left hand limit equal to right hand limit, which is equal to limit of f of x. So we get a plus b equal to 4 and b minus a equal to 4. Cancelling a, we get 2b equal to 8. So b is 4. Put b 4 in first equation so that we can get 4 minus 4. So a equal to 0. The possible values of a and b are 0 and 4 respectively. Question number 31. If the function f of x satisfies limit x tends to 1 f of x minus 2 by x square minus 1 which is equal to pi, evaluate limit x tends to 1 f of x. So this function is given as pi. So simplifying this, get limit x tends to 1 f of x minus 2 which is equal to pi into limit x tends to 1 x square minus 1, which is limit x tends to 1 f of x minus 2 which is equal to pi into, at x equal to 1 we have 1 square minus 1 which is 0. So pi into 0 is 0. So we get limit x tends to 1 f of x minus 2 equal to 0. We can write this as limit x tends to 1 f of x minus limit x tends to 1 2 which is equal to 0, which is nothing but limit x tends to 1 f of x minus 2 which is equal to 0. Therefore limit x tends to 1 f of x equal to 2. Question 32. If f of x equal to mx square plus n, x is less than 0, nx plus m, x lies between 0 and 1, nx square plus m, and x is greater than 1, for what integers m and n does limit x tends to 0 f of x and limit x tends to 1 f of x exist? So we have to find left hand limit f of x which is equal to limit x tends to 0. To the left of 0 we have the function mx square plus n. Put x equal to 0, we have n. Now we have to find right hand limit x tends to 0 plus f of x which is equal to the right of 0 we have the function nx square plus m. So limit x tends to 0 plus nx square plus m, put x equal to 0, we have m. Thus limit x tends to 0 f of x exists if m equal to n. If both are equal, if left hand limit and right hand limit are equal, then we can say that limit f of x exists. Conversely, limit x tends to 0 f of x exists if m equal to n. Left hand limit x tends to 1 minus f of x which is equal to limit x tends to 1 minus nx plus m. To the left of 1 we have nx plus m. Put x equal to 1, we have n plus m. So right hand limit f of x which is equal to limit x tends to 1 plus the function is nx square plus m. Put n equal to 1, we have n plus m. So left hand limit x tends to 1 minus f of x which is equal to right hand limit 1 plus f of x which is equal to limit x tends to 1 f of x. Thus limit x tends to 1 f of x exists for any integral value of m and n. Thank you children.